There's one type of system of linear equations that turns out to be quite important. It's the case when B is a tuple of all zeros. Such a system is called a homogeneous system. To see why this kind of system is important, let's look at an example. Say the matrix A is given by this, and B is a tuple 6, 7, 8. Now notice that A is already in reduced row echelon form, and the pivot columns are column 1, column 3, and column 5. So the three variables are x2, x4, and x6, and I'm going to set x2 to S, x4 to T, and x6 to U. That will give me the following solution. So x1 will be 6 minus 2s plus t minus 3u. x2 is s. x3 is 7 plus t minus 4u. x4 is t. x5 is 8 minus 5u. And x6 is u. And I'm going to separate things a bit. So this is given by 607080 plus s times, I have minus 2 in the first entry and 1 in the second entry. Those are the coefficients for s, and 0 everywhere else because s does not appear in the third, fourth, fifth, and sixth entry here. And then plus t times 1 0 1 1 0 0, and then plus u times minus 3 0 minus 4 0 minus 5 1. So for every choice of real numbers s, t, and u, I get a solution to the system ax equal to b. If you look at these three tuples here, they satisfy the system ax equal to 0. And you can easily check that. So these three tuples satisfy the homogeneous system, whereas this tuple here satisfies the original system. As a result, what we have here in front of us is a particular solution to the original system plus a linear combination of solutions to the homogeneous system. And in general, we can always express all the solutions to ax equal to b with a particular solution plus a linear combination of solutions to the corresponding homogeneous system. So let me write down the details here. So suppose that x star and x prime satisfy ax star equal to b and ax prime equal to b. So both x star and x prime are solutions to ax equal to b. Now if you look at the difference, what you get is ax star minus ax prime, and that's equal to b minus b, and that's 0. So this difference here is a solution to the homogeneous system ax equal to 0. If x star is a solution to the system ax equal to b, then all the solutions to ax equal to b is given by the set x star plus d, where a d is 0. Now, we usually denote the set of d satisfying a d equal to 0 by n of a. And now you see why we are interested in studying homogeneous systems, because knowing all the solutions to the system ax equal to 0 can help us find all the solutions to ax equal to b. And in a future video, we'll take a closer look at this set, and we'll see how it eventually leads us to the topic of vector spaces.